Handling repetition. So repetition is all about looping within software development. And if you haven't heard of a loop before, loops just give us a way to, again, control the flow of execution within our application, control the flow. So whether we need to run a block of code a certain number of times or we need to run a block of code until a condition is met, that's what loops are all about. And loops are used everywhere today in software development. In fact, if you're going to build an application such as maybe a business application that uses data stored in a database or data stored in arrays or data stored in a collection of classes, uh, you know, that's one method. Or even if you're developing a video games are based on loops. That's really the heart of a video game is the game loop, and it's constantly running and checking conditions and re-rendering the screen and checking for user input and doing all that sorts of stuff. So loops are an important core programming construct that we need to understand, and we're going to take a good look at them here in this nugget. So let's start it off with a look at the outline. And in this nugget, we're going to start with an introduction to looping. Here, I just want to get you familiar again with what a loop is. We'll get some real-world analogies going. I want to get you familiar with the structure of a loop, all the main points that we need in order to successfully create a loop. And then we'll take a look at the 4 different kinds of loops. So once we get all that under our belts here, we'll jump right into C# over in Nugget Lab and take a look at how to work with loops. So we'll take first just a basic example of all the different types of loops, just to get you familiar with the syntax and how they work. And then we'll get into a real-world demo, and I'll show you how we can take data stored in a collection of objects and load up a list view with it inside of a WinForm application. So that'll look cool, and it's a great example because these are the kinds of things I do in almost everyday programming life is loading lists with data. Very popular thing to do these days. And then we'll take a look at how to implement recursion. And recursion is more of a programming method that uses looping in order to divide and conquer something. So think of it like that. We'll get some more real-world analogies going when we get into recursion, but it's really just a way for a method to call itself over and over and over until it's done. So it's a good way to solve things like mazes, and for us, in our real-world example here, a good way to make a directory searcher where you type in a path within the file system, and then our recursive function will call itself over and over to go through all the subdirectories, pull the files out until it's completely done and back through the top of the loop. So we'll get some good examples going of recursion as well. So let's start it up here and get familiar with an introduction to looping. So looping, as I mentioned, allows us to execute a block of code until a condition is met. And let's take a real-world analogy. Let's say that we had a clock, and not just any clock. Let's say it's an alarm clock. Now, a clock is constantly looping through it at many different levels. It's looping through seconds, it's looping through minutes, it's looping through hours. But an alarm clock, we're usually going to set that at the minute level. So we'll set an alarm clock for a time, like say, 7:05 or something like that, right? If we set an alarm clock at the minute time, what'll happen is every minute that ticks by, every time a minute hits through the loop, that's going to be our condition, is going to be the actual time set on the alarm. So what it'll do is at the beginning of every minute, the loop will check its condition, meaning the alarm set time, with the current time. And if those values are true, that means our condition is true. And then what'll happen? Well, that obnoxious sound will play that'll try to wake us up, right? And then it'll continue going. So the clock is kind of a tough analogy simply because there's really no break point because time doesn't really stop, right? So the clock would be a good one for an infinite loop, and an infinite loop can happen, when a loop is poorly designed, and that would mean it would just execute forever and the application would hang. So I'll show you how we can prevent that from happening. But the clock is going to be a great analogy when it comes to recursion. So we're going to come back to this when we get to recursion. A better analogy is a racetrack. And let's learn about the structure of a loop while we go through our racetrack analogy here. So there's 3 main parts to a loop: the initializer, the loop test, and the loop counter. The initializer is what we're going to use to keep track of where we are in the loop. So inside of a racetrack analogy here, our initializer is going to probably be 1 because we're going to start on lap 1. So this is how we're going to keep track of laps, is through our initializing variable here. In this case, it's going to be I. Our loop test is going to be our termination condition. So as long as our loop test is true, we're going to continue looping. So how many laps are we going to run inside of our race here? Let's just say 50. So as long as I, the current lap we're on, is less than or equal to 50, we're going to allow the racers to keep going. They're going to keep looping through the track. And finally here, we need a way to increment the current lap we're on. So we would do an I++ in this case, which would increment it by 1 at the end of the loop. So we would move it to loop 2. That way our termination expression will be hit. If we don't do this, if we don't manage our loop counter and increment it, guess what? We'll create an infinite loop. We'll sit in this loop forever because we'll always be on lap 1. So this is why at the end of the loop, we just increment it by 1. Now in the .NET Framework, we have 4 different types of loops. We have the while and do-while loop, which operate on a Boolean condition. We have the for loop, which operates on an expression. And we have a for each loop, which allows us to iterate through a collection. So starting with the while and do-while, these have been around for a very long time in a lot of programming languages. And they're starting to show their age because there's a lot of manual work with the while and do-while. See this loop structure that we were talking about? We're completely responsible for this. So we have to declare these variables outside of the loop, manage them inside of the loop, and make sure that we increment them ourselves. So there's a lot of extra code when working with while and do-while loops simply because you have to manage this stuff in and outside of the loops. With the for loop, this is a very nice way to do things because all this stuff is built into the loop. It's built right into the statement itself, into the declaration of the statement. So we just set it once in one area and it's done managing loops. No variables outside of the loop that we have to manage the actual loop itself. And finally here we have the for each loop. And this is everyone's favorite kind of loop because it's very easy to work with, get the hang of, and it's syntactically much cleaner. And the reason is because with the for each loop, we don't have any of this stuff. We don't have an initializer, a loop test, and a loop counter. We just simply loop through an array or loop through a collection, and then we can reference the object directly inside of that collection. Where if we were to loop through an array or a collection using a for loop or a while or do-while loop, then we need to reference the item in that collection by index using our counter. So there are still times where you'll need the for loop when you do need to do indexed operations and when the for each isn't supported. So if you're not working with a collection that supports the interface, that a for each can iterate through. While and do-while you won't see used very often these days just because you can usually do it better with a for loop. But they are there for completeness sake, so we'll take a look at how to use them as well. Alright, let's jump over to Nugget Lab and take a look at how we can work with loops. So we'll minimize the whiteboard, head over to Nugget Lab, and as soon as this fires up, we're going to go to the Start button, up to Visual C# 2010 Express, and launch it. And in here I created a solution called O4-handling_repetition. And in here I have 2 projects. We have a console project, and this project we'll use here just to get familiar with all the basic looping constructs and how to use them with simple examples. And then we'll jump into a WinForm application here where I have a couple of forms and we'll take a look at how to use them in real-world scenarios. So you can see in here I've got 4 methods set up: a while loop method, do-while loop method, for loop method, and a for each loop method. And we're going to use these methods just to get the hang of the syntax of loops. And we'll do a very simple loop for each one of these. Let's start with the while loop. And you can see I've got kind of the structure set up here inside here just to output some data to the console window here. That way we can focus on the loop and you don't have to watch me type all that. So focusing on the loop now, what we need to do first is create a counter, because with a while loop and a do-while loop we need to manage where we are in the loop. So let's just do an int counter equals 0, and now we have our initializer set up. Now we need to start creating the shell of the loop. So if we do a while, hit tab twice, it's going to create the shell of the loop for us. And it's very similar to an if statement where we have our while followed by our condition followed by the code to execute inside of the loop. So let's create our condition here being as long as counter is less than or equal to 100, loop. So we're just going to output the counter to the window. So we're just basically doing a very simple counting application where we're just going to count using our console commands here. So if we do a console.writeLine and send to the output window just counter, just the value of counter, we've got to send it to a string here since that's going to return an integer. That's that. Now if we were to run this right now, we would create an infinite loop because we're not managing our counter here. We're not incrementing it by 1. So we would always be 0 and it would constantly output 0 to the console window. So this is the important part here. We got to do a counter plus plus. And that's that. So now the loop is complete. It's going to start at 0 with our initializer and run and increment it every time it's done with the loop. So it's going to constantly do this, and we should get the result of counting from 0 to 100 in the console window. So let's just call this from our main method here, while loop, and that should do it. If we hold control down and hit F5, check it out. And that was very fast, obviously, because we've got a fast computer here. So if we up this to say 10,000, maybe we'll see it a little better. And I'm going to hit control F5. There you go. You can see it a little bit better anyway. Counted to 10,000. So that's a while loop. Now let's move on to a do-while loop, which is really the same thing as a while loop, except that we can check our condition at the end of the loop rather than at the beginning of the loop. But let's do something a little more interesting than that. So let's let's do the same thing. Let's count to whatever we want to here. Only let's ask the user every 100 if they want to continue counting. So we're going to need an extra variable to do this. And what we're going to do is create a Boolean variable. And let's just call this keep going. And we're going to set it equal to true right off the bat here. And then we still need a counter to manage where we are in the loop. So let's create a counter as well here. Int counter equals 0. And so we've got our variables set up. So these are the variables we'll use inside of our loop to manage it. And now let's create a do loop. And we just type do, hit tab twice, and now we will get the structure set up. And here's the structure. You can see we have our condition at the end of the loop this time. And we're going to loop this time as long as keep going equals true. Just like so. So the first thing we want to do is just output to the console window the value of counter. So let's just do the same thing we did above here, console.writeLine. And we're going to output counter.toString, just like so. Now the next thing we need to do is ask the user if they want to keep going if the number that we're currently at, the counter, is divisible by 100. So we have to do a little bit of math here. And we're going to do an if statement first to find out if that's the case. So let's just create some math here. Let's say if counter modulo 100 equals 0, and the counter, where are you, counter? There you go, does not equal 0, then we're going to ask them a question. So what does this do? Well, modulus, this is a useful operator here for a variety of situations, but what we're using it for here is to find out if the counter is divisible by 100. So modulus returns you the remainder. Think of it as returning the remainder based on a number that you're dividing it by. So as long as the counter coming in, modulus 100 equals 0, the remainder is 0 on it, then the number, counter, is divisible by 100. And then we're doing a check here to make sure counter does not equal 0 so we don't ask them right away the very first time in the loop. Alright, so that's all that'll do. The next thing we'll need to do is a console.writeLine and ask them if this is the case, if this is true, and we're divisible by 100 here. Keep counting, and we'll give them a little instruction here, yes or no. Now we need to find out what they entered into the console window. So let's just do a console. Actually, let's do an if statement. I'll wrap this into one here. If console.readLine does not equal y, then what we're going to do is set keep going equal to false. That's it. Now let's just take a second to analyze what we're doing here. And by the way, this should say counting, not counter. My brain's turning into a loop. So keep counting. There we go. Now what we did is we're just writing an if statement and saying if console.readLine does not equal y. So if it's anything other than y that they type into the console window, we're going to treat it as a no. And we'll set our keep going variable from true to false. So when the condition is hit down here, it'll immediately stop counting and the application will be done, or the loop will be done. So the only other thing we need to do down here is manage our variable. So we'll do a counter plus plus, and there we go. So if we want to see this in action, let's just go up to our entry point and make sure we call the do while loop construct, just like so. Now if we hit Control F5, there it is. Now if we want to keep counting, we hit yes here. It's going to keep going. So I can do this all day long, and it's going to keep on counting until I hit no or anything other than no. So let's hit no. There it is. Press any key to continue. So it broke out of the loop at that point. So that's how we can implement the do while loop, basing it on a Boolean variable. But we can also do this without a variable. And this is more control flow stuff here, because what you can do, let's do this. Let's comment out our Boolean, comment out our keep going, and then let's just set while equal to true. So you're like, what's going on here? We're going to create an infinite loop because it's always going to be true. Well, this is where the break statement comes in. Instead of managing a variable here, we can just hit break. So if we call break when they hit anything other than y, it's going to immediately get out of the loop. So this is a great way to control your loops. If you need to do any conditions, you don't need to have a bunch of variables in here to track all those conditions. You can just track them on the fly and then call the break statement. Now let's head down to the for loop and see how this is a cleaner and easier syntax to work with, because we don't have to mess around with all those external variables. So if we expand our loop for loop method here, let's just start typing in for, hit tab twice, and there's a structure. So see what it did there is it wrapped all the variables that we used above when it comes to our counter inside of the initialization, the declaration of the for loop. So it kind of creates within it int I equals 0, and as long as, let's say, I is less than or equal to 100, continue the loop, and here's our increment or decrement counter. You can also go backwards if you do a minus minus on this. So if you wanted to count backwards from 100, you could do that as well. You could set I equal to 0, and as long as I was greater than or equal to 0, and then we can do an I minus minus. So you could certainly reverse it. But you can see much easier. We don't have to manage these variables outside of the loop. You just set up your declaration of the statement here, all of our initializers, our test, and then our counter, and we're good to go. Now we can just do a console.writeLine counter.toString. Oops, sorry. I. So used to writing counter there. I.toString. There you go. And you can change this, by the way. If we wanted to change this to counter, we certainly could. But I is easy. That's kind of the, what everybody uses these days when doing loops, just because it's built right into it here when you create the statement. So this is it, though. That's all there is to a for loop, and it's just much cleaner syntax, less variables, less code, and less code is always good because it makes it easier to look at. So let's head on up here, change this to a for loop. So we call our for loop method down here, and now I'm going to hit Control F5 to run it, and there it is, same result. Now let's move on to the for each loop, and again, a fantastic loop here to get the hang of because it's got so many uses out there and makes it really easy for looping through arrays and collections. So the first thing we're going to do is we need to create an array here with a bunch of data in it. So I'm just going to paste in from the clipboard a variable that I created here. So this is a string array named data, and we've got 6 elements in here. 1, 2, 3, 4, 5, 6. This is a string array, and what we're going to do is we're going to take this array and concatenate it into one string and output it to the user as a string. So we need to create a variable here to store the result. So let's call this result data, and that looks good. And in fact, you'll notice this green squiggly line here that says a variable result data is declared but never used. So if you want to do something like this, initialize it to a string.empty. That way, it's a little more readable. Looks a little better too. So there you go, string.empty. Now we don't get the green squiggly line. So if we want to do a for each here, we start typing out for each, we can hit tab twice, and there we go. We'll get the structure of the for each loop. And how this works is we need to create a variable first that'll be the placeholder for the item coming in the current item in the collection that we're looping through. So this is going to be a string because that's the kind of data we're looping here through. So let's call it a string, and let's just say S for string. So that's how we'll refer to the current item in the collection. And now our collection that we're looping through is data, so let's just call that data. So the first time this loop is ran, on the first iteration, S is going to hold the word this, the string this. The next time it's going to be is, then string, then array, so on and so forth. So what we're going to do is we're going to store the result into result data. So let's do a result data plus equals S. And now let's just output to the console window using a WriteLine the value of result data. There we go. So we're just appending for every element in here. We're just going to append the value into result data. And let's take a look at what this would look like here. Let's go up to our main entry point. Let's just call the for each loop, just like so. Head back down to where we were in our code here. I'm just going to Control F5, and you can see we're going to get one big long string. This is a string array as one word. Now, if we wanted to make that a little prettier, we could do something like this: string.format, and in our format here, we just want to do a 0 with a space. So that way, it's going to use the value of S, toss it inside of the result data with a space after. Now if we hit Control F5, we'll get this is a string array with a little space there after period as well. And actually, that's one of the few issues here at the for each is we don't have a way to find out where we are in the loop through the index. So if we wanted to take that space off a period, right now we'd have a tough way to doing it because we wouldn't know that we're in the last element in the index. And that's where we could create a counter here. And so we could tell based on the counter, if the counter equals the data.length, which will give us the count of how many are in here, then we could certainly trim the string off here using an if statement. So just wanted to point that out. That's the benefit of the for loop, is you can do indexed operations, find out where you are in arrays and collections and such. But that should give us a good understanding here of the syntax of all the basic loops. Now what I want to do is take in and give you a little bit more of a real-world example of how we would use loops in everyday programming. All right, let's take a look at how we can use loops in a real-world environment. Kind of a real-world example here, something you will definitely do in your programming days, especially when working with collections and data. So let's close out of our console application here, and let's just right-click on our WinForm application, set it as a startup project, and we have our loops form set as the current startup form here inside of our program. So as soon as we run this application, our loops form will show, and if we look at it, what we're going to do is we're going to load up people data that is stored inside of a collection of people. And to give you kind of a brief overview, we are going to use classes. If you're not familiar with classes, don't worry about it. We got plenty of nuggets ahead based on how to work with object-oriented programming and classes. But just to give you a quick rundown, we've got this person class, and this just represents a person. So we can create a person object and then do person.firstname equals and then the first name of the person, last name, position, and home world. So a very simple class here just to track person data. And then we have this data class. And this data class utilizes that person class to create a list of people. So we create a list here based on the person type. We call it people. And now we're just creating those people, those person objects on the fly. So we're doing by adding it into this people collection by creating a new person and setting all the values here. First name, last name, position, and home world. All the way down. So we get a bunch of people inside of this list. So all we need to do to get this list is a data.getPeople, and that will give us a people list, which is a collection of person objects. So we're going to create a loop, both a while loop and a for each loop, so you can see the differences here and how we can loop through a collection filled with object data and load it into this list view. So let's start with the while loop. And if we go into the code here for the while loop, I've got it pre-written. The first thing we do is we just call exactly that, data.getPeople. We create our own local people variable, which is a list of person objects. All right, so this will just simply be a list of a bunch of people. Now with the while loop, again, we need to create our counter here so we can keep track of where we are in the loop. So our condition is going to be as long as counter is less than the count of people within here, -1. And the reason we have to do a -1 is because our counter starts at 0. And the count on any collection is going to return the actual count starting at 1. So, and you know, we could start this counter at 1 and then get rid of the -1 there, but you'll see a lot of things in programming are 0 based, so it's good to keep it consistent here. So all we're doing is we're looping through each person inside of this people collection. We're creating a list view item. So the list view itself here contains a bunch of list view items, line by line. So what we're doing is we're creating a list view item, calling it LVI person. We're setting it equal to a new list view item because we're working with objects here. And we put into this because the constructor, when you create an object, it has a constructor here. This is what it's going to expect. And it's got a bunch of things here. Here's one we're providing it. The string, which is going to be the very first column inside of that list view, we're going to set it equal to the first name. And then the image index we're setting to 0. What that is I have an image list down here with an image inside of it. You can see there's our person image. And it's only one image, so it's an index of 0. And then I just tied this image list to the list view through what's called the small image list property. And that way we can reference what images we want loaded in here for each item. So that's all that 0 is there. And then all we do is add a bunch of sub-items. So think of a sub-item as a column within the list here. We're going to add the last name, the position, and the home world in this order so they line up like so. So once we construct our list view item, now we can add it to our list view itself. So our list view, the name of it's LV people. We do a .items.add, pass in the person, the LVI person list view item that we just created, and that will add it to the list. And then since we're working with the while loop, we have to manage these counters, so we just do a counter plus plus so we don't infinitely loop and add the same first person over and over again. And the results of this, if we run the application here and we hit the load people, looks like so. There we are. I fit well in there with all these Jedi Knights, captains, and bounty hunters, right? There we go. So that's a while loop. Now we could easily rewrite this with a for loop as well. In fact, let's just highlight all this code here for our while loop. Let's comment it out. And then let's highlight all of our for code, uncomment it out. And here's how this looks. So same thing, we're just, again, not managing the counters here. And the other difference is that we just have an I here. Because again, you have to reference these things since we're using an index kind of looping here. We have to reference the data within our collection by index. That's why you see a people and then a counter up here and a people I down here. That's when we go into the collection, it's going to pull out that person. So that's why this counter is very important, because it keeps track of not only where we are in the loop, but where we are when we're looping through things like collections. All the other code is the exact same, and if we hit run here and hit again, There's a result. So that's it for while and for loops. Let's go down to our for each loop, because that's really what these collections are made for. They're much easier to loop against a collection using a for each than it is with a while, a do while, or even a for loop. And look at how much little code it is. Not only is it little code, but you don't have to use this index stuff where you're referencing things in your collection by indexes, because we're iterating through each person inside of the collection. So we're doing a for each person. Since we're working with person objects, we're going to use the placeholder P here so we can work with it by referencing P in our people collection. And this is just a different way to initialize a list view item. We could have used the same way above here, using those sub items to add it in. But this is just taking a string array. So we're creating an array and then using a p.firstname, p.lastname, p.position, and p.homeworld. So that's one line of code there to initialize our list view item, and then we just add it to the list view. And the result will be the exact same if we hit run, hit load people using the for each. There it is. Now the last thing I want to get you familiar with here is recursion. And again, recursion is just a programming technique that allows us to pretty much find all possible values, and a method that can call itself over and over again until it can find its way out. And to give you an example here, let's get out of Nugget Lab and back into the slide just for a second. When we're talking about clocks, for instance, a clock reuses itself over and over. Whether you're talking about hours, minutes, or seconds, it's reusing itself. Because at the hour level, it's going to use minutes and constantly calculate minutes until it gets to the hour, and then it's going to increment the hour. And same with seconds. It's going to increment the minutes when it gets through a full second. And another analogy here is mirrors. If you take two mirrors and put them facing each other and you stand in between them, you're going to see an image. The mirror constantly uses itself to reflect that image over and over again within itself. So that's kind of what recursion is. And I think the best way to get an understanding of recursion is to see a good example of it used in computers here. So let's head over to Nugget Lab again, and I've got an example set up. I've built a directory searcher. We've got the recursion form here. Let me just go into our program.cs and let's change our startup form to recursion. There we go. And we'll go through the code here. Let me just first run it to give you an example here. If we run this, and let's just type in C:\Windows, and we're going to include subfolders here and hit get files. Now this may take a little bit because it's going to recurse all the folders inside of the Windows directory here on the hard drive. But what this is doing, using including subfolders, is I have a routine in here called get directories. And what that is doing is it's recursively calling itself whenever it hits a directory. In fact, if we find one here, here's one. See how this has a directory within a directory? Well, I've got a method here that actually recalls itself to get the directory. So this is only one method working this. And this is kind of a cool little application here because it's a nice little directory searcher. And again here, it just shows recursion perfectly. So let's take a look at the code. So I'm going to double click on get files, and inside of our get files button, here's the code. And I'm just going to minimize our font a little bit here so we can get a better view of it. But all this form consists of is this right here. That's it. We've got our get files button that we just clicked on, and then we've got our get directory files, and this is going to be our recursive function that's going to call itself, as you'll see at the bottom here, get directory files. So it's actually calling itself, and we're only going to do this if our checkbox here, include subfolders, is checked. So this is really our recursion. We call this CB recursive. So as long as this is checked, it's going to call itself to get all the subdirectories within a directory. And if there's subdirectories within the subdirectories, it'll do it all. So you can see how it's kind of divide and conquer, because it's going to go and keep going until it reaches the end and can then find its way back out. So let's head back up into our button code. And the first thing we're doing here is we're just getting the path that the user typed into the text box right here. And then we're going to store the value that they typed into the text box, calling path.getFullPath. So this just protects us so we don't have to handle the spaces, because if there's a space in the path, this will take care of it. If we didn't do this, then we'd get an error saying that that path didn't exist. So that'll take care of that. Then we're going to create a tree node. So this is going to be the root node. And we're just adding to the root node the value of the user path. And then the same thing here with image indexes. I just have an image list set up with a folder to represent a folder and a file to represent a file. And then we create a directory object. And by the way, to access this kind of stuff, you need access to using system.io. So this namespace contains all this stuff we're working with, directories and the path object here. So we create a directory info object based on the path that the user types in, and then what we do is call our get directory files. So this is what starts it all, is we call the get directory files passing in our root directory and the root node of the tree. And don't worry about this expand, we'll get to there. That's going to be the very last code that's run because it's got to go through all this recursion inside of here, and this is just going to expand the root node by default. Now our recursive function get directory files takes a directory and then takes the parent node. And the first thing we do in here is we create an array of directory info object called DIRs, and we call the directory, which is the root directory that got passed in this case, .get directories. And a star.star will get us everything. Now what we need to do is we need to create a for each loop to iterate through all the directories. So that's what we do. We set up a for each loop. So we have a dir variable of directory info type, so we can have a placeholder there for each directory inside of our directory info array, right? Great use of a for each right here. So once we do that, we're going to add to the tree node this directory. So this is going to be a child node of our root node here, in this case, in the first loop through. So we're doing that, we're just adding it to the parent node. So we're going to create a child node tree node by creating a parent node.nodes.add, passing in the name of the directory, and that'll get us a node object here, and we're going to set the image equal to 0, which is our directory, because we know we're in the directories here. And the next thing we're going to do is create a file info array of file objects, calling it dir, meaning for the placeholder in the current directory in an array, .get files, and also we want to get every file. Right, so this will give us the files, and now we're going to loop through all of the files in this directory and add it to the tree as well. And now this is the part that does the loop, because again here we're going to do an if, the recursive checkbox is checked, then it's going to call itself. And because we're calling itself while we're already in a loop for this directory, it's going to immediately jump out and fill all of the directories within the current directory. So it's going to start at the root directory, get the first directory. If that directory has any subdirectories, it's going to go through those one at a time as well. So you can see how it's a divide and conquer. And I think the best way to do this is to actually see the code happen. So let's set a breakpoint right here at get directory files. And I actually created, if we open Windows Explorer here by right-clicking on the Start button and choose Open Windows Explorer, inside of the C drive I created a directory called Test. Then test 2 is in it, test 3.3 and 3.1 is in with that, and test 4. So we've got a nice array of subdirectories and directories here that contain other directories. So this is a perfect example for recursion. Now I don't have any files in here, so we're only going to see directories when we do this. But if we were to run this in debug mode, type in c:\test, make sure include subfolders is checked, and hit get files, it's going to pause this right here. And I'm going to hit F11. F11 is the same as hitting this right here, step into. And we're going to go right into our get directory files procedure. And now a good thing to do here is monitor the call stack. See, the call stack tells us where we currently are in our code execution. So the first thing we did was hit the get files button, btn.getfiles. And now, since we just F11'd into get directory files, we've moved into get directory files. So this is our call stack, and eventually we'll have to get back to our get files so we can call this last line of code and be done, and the form will show. So the first time through get directories here, we're again working with our root directory. So if we hold your mouse over directory, you can see that's the directory, c:\test. I'm going to hit F11 a couple of times. And how many directories here are within our root directory? Well, just one, called test2. And that's what this directory.getDirectories returned. And now we're going to loop through that one directory. So if I keep hitting F11 here, you can see we're going to start looping through it. So that we're currently working with the test2 directory. It's going to add the test2 directory to the tree view with the image index of 0, which is our folder, and then it's going to call a file, get the directory here by calling get files on the directory. So even though there's no files in here, this is going to return nothing. In fact, if we hit F11 and hold our mouse over files, you'll see it returns 0 because there are no files. I didn't create any files, just directories. So if we hit F11 a few times here, it should skip right over that loop. And the last thing it's going to do is see if recursion is checked, which it is. So that means it's going to call itself. So as soon as I hit F11 here, you're going to see another get directories get added to the call stack. And there it is. So now we're nested. We're recursing itself here because it called itself. And now we're going to loop through all the directories inside of our test2 directory. So if I keep hitting F11, now it's going to look for all the directories inside of test2, which there should be 2. I added a 3 and a 3.1. And there it is. There's 3 and there's 3.1. And now it's going to loop through each of these directories, look for files, which there are none, and then it's going to recurse. It's going to start with 3, as you can see here, test3. So now we're we're getting pretty deep here inside of our recursion, and it's not going to find anything inside of 3 because there are no directories in 3, so it jumps right out of it. But once it goes into 3.1, it is going to find a directory because there are directory number 4 in there. So once we get down here to our recursion, it's going to call it once again. All right. So even though it got out of 1, now we went back into 1. That's why it went from 2 to 3, and then back to 2, and now we're back to 3 again. So if we keep looping through here, it's going to find directory number 4 here, and that's going to be it. So I'll hit F5 here. You can see actually now we're in directory 4. See that? We're 4 deep. So if I hit F5, it's going to finish this, and the result will look like this. So we've conquered our directory structure here using recursion, which just again simply calls itself over and over again until it can't go any further, and then it just starts unwinding, as we saw there. So play with this demo application if you can, and just do what I did here. Set breakpoints, walk through the code to get a good understanding of how it works. But it's pretty straightforward. There's really not a lot to it. There's not a lot of code here to analyze because there's just not a lot of code here. All right, so in this CBT Nugget, we took a look at handling repetition. We started off here with just the basics of what a loop is, got some real-world analogies there, and then took a look at the loop structure and saw the 4 different types of loops we have to work with here: the while, the do while, the for, and the for each, and got familiar with the differences between them. Then we jumped into a big lab here on Nugget Lab and got just a basic example of the 4 different kinds of loops, just to get the hang of their syntax and get familiar with how they look in code. And then we jumped in, I gave you a real-world example there of how you would load a list view with data stored in a collection of person objects. And at the end here, we looked at recursion and saw how we could create a recursive method to go through and iterate through all the directories, subdirectories, and directories of directories within an operating system. I hope this has been informative for you, and I thank you for viewing.